name is Darren Thomas. I'm the Director of Educational Research Techniques, and we are in Unit 2, Lesson 2, where we're looking at decision trees for numeric prediction. And so in this particular lesson, we're going to be looking at data preparation. So we're going to go ahead and move over to RStudio and see what's going on there. So you can see that I'm inside RStudio now, and the code of the course is up in the upper left-hand corner. Now, we're going to first load our packages. That's found in line 2 of our code. And so you can see we're using several packages here. ECDAT, RPART, Rattle, and RECA. So ECDAT, that is where our actual data set is. I'm going to talk about that more in a moment. RPART is for the making the decision tree. Rattle is for visualization, and RECA serves another purpose as well. Now, to load our actual data, we just type in data right here in line 3, Control Enter. Now our data is loaded, and we can use the str function in line 4 to kind of get an idea of what the data is like. So you can see right here that we have 1, 2, it even tells you, I'm sorry, right here it tells you how many variables, 8, and it tells you how many observations, 4,856. And we know all the different types of variables here. They're all integers except for married, where we have several different levels here. So in line 5, we have something called the summary function, which just kind of gives us a visualization of what, or not a visualization, but a summary of what our data is like. So I'm going to run that again so that we can see it a little bit better. And so here's a brief outline of the different characteristics of our variables. So if I had to zoom in, but I'm sure you can see that, but I'll make it a little bit bigger. So you can see right here, it tells you the interquartile, the quartile ranges, the max. It tells you the mean, all these things like this for all of our variables here. Now, one thing I want to point out that you should be looking at that's kind of weird, is especially for the education variable here, educat_in, is that we have a max of 99. That's kind of strange. People don't go through 99 years of school, so that's something we're going to have to address. Another one that we might want to look at is, of course, kids. You can see right here for kids it goes up to 99. Again, nobody has 99 children. That's a little bit strange as well. So we're going to have to deal with that as well. And then down here we have the information for the categorical data of married. 3,071 are married, 681 are never married, etc., etc. Now, if we were doing more advanced analysis, we might want to combine some of these, like NADF is so small that probably could just remove that data, and you might want to combine NADF with no history or something, whatever. But for our purposes, we're going to stick to what we have here. So we're going to go ahead and zoom out. All right, so now we're just going to look at some histograms of the different, the different continuous variables that we have. So in line 6, I run for age. You can see there, this is expected for count data. There's a little decline like that. Education, you can see most people have it to grade 20. Then there's a huge gap because we have those people coded as 99. And then here for earnings, again, this is to be expected. A lot of people make almost nothing. Handful of people make a whole lot of money. Again, if we were really serious about this, we would probably remove these extreme values up here. Hours worked, a little bit more balance. Number of kids, again, everybody has almost no kids. A handful of people have a lot of kids. Again, this should be a sign that there's something wrong that we have to deal with. Now, what we're going to do now in line 11 is look at the categorical data by using the table. So I'm going to go over here, and you can see this information was seen in the summary section. We already saw that. Now, here's what's going to happen. In lines 12 and 13, what we're going to do is this. We're going to recode the kid variable, because some of the values were marked as 99. And if you really want to know why, there's a way to do that inside RStudio. So let me slow down for a second and show you. If I type $PSID, it should show me the data about the details about the data set. So PSID stands for Panel Survey of Income Dynamics. This is again from the ECDAT package, and it tells you the characteristics of the data, excuse me, right here. And so for kids, live birth to the individual. Now this doesn't give you all the information. You would have to go to the online and find out. But if you went online, you would find out that like 98 means like never, like unknown, and 99 means no kids or something. And this kind of coding is not going to work for our purposes here. So we have to recode this. So this is what we're going to do. we have 98s and 99s in the kid variable. So right now, R is going to think that someone has 98 kids and has 99 kids. What we're going to do is we're going to change that 98 to a 3. In other words, wherever there's a 98 or greater, so a 98 or a 99 is going to be recoded as a 3. So as someone who has 3 kids. Is this the best way to do it? That's not the point. We could put the mean in there at 2 or whatever we want. But for our purposes, we're going to replace the 98s and the 99s with the value of 3. That's what line 12 is. And in line 13, we do something similar here, but this time we're dealing with the education variable. And so anything that's coded 98 or 99, we're going to code it as 12, which means that they completed grade 12 of their education. So we do that, and now we're just going to take a quick look at the education variable in line 14 for a second time to see how it's changed. And so you can see it's a lot more spread out. We don't have a huge gap and then a handful of people at 98, 99. That's all gone. It stops at around 15, 16 or so. So graduate school, that makes sense. Now, in the last 2 lines of code, all we're going to do, this is line 16 to 17, is just divide the data set. So rows 1 to 3,642 will be in the train set, and then the last rows, about another 1,800 or so, will be in the test set. Now, this is not always the best way to do this. You can randomize your data and randomly pick, but this is just another way to accomplish it for our purposes in this particular course. So I take the first 3,600 rows, and then I take the last 800 rows that are left over, and now I have my train and test sets. And notice the name I gave them, PSID train, PSID test. That's what I called them. And so having gone through this process, we are essentially done with the data preparation. So in the next video, we will begin working on developing our model and making predictions with it and trying to assess its performance. So that's what we're going to do. So I want to thank you for watching this video, and we'll see you in the next video. Thank you. Take care.